Hi, hello everybody. I wanted to create a short video to show you exactly how you guys are going to start using SASM this semester, okay? So I have an icon here, so you would click on your icon. By the way, this is assuming you already downloaded and installed SASM, the Microsoft assembler, and the libraries I told you to install, okay? So you can see that on Blackboard if you haven't done that yet. So you click on the icon to start, file new, and when you do that, you see this thing right here. So completely delete everything that you see here, and you're going to type the code the way that we do it in class. And I have here for you guys something basic that you would start. Now I'm going to start from a basic file that I have. This is an empty shell. So your code is going to look pretty much the same. You know, type your name, description, the libraries you have to have. Now, I told you to install them in a known folder. I have them in the folder called ASM IO. Do not change none of the files you have there. I changed them just exactly the way they're supposed to be so that you can work with libraries and have an easier time in this course. You have a constant section, .constant. You have a data question mark section for initialized data. You have a .data section, and you have a .code section. So in assembler, everything has a segment. Okay, so don't worry so much about what these segments are right now, but we have to have them. All right, so you would type all of this stuff in. Anything that you see here in green is a comment. All right, comments in our assembler are initialized with a semicolon. And this is where our code has to live. Okay, we can only code the program inside a .code segment. We'll begin the program with main proc, main procedure. Everything is a procedure in assembly, just like some other languages. It's going to end with main end P for end procedure. And so this ends the procedure main, and then we'll have to have an end main. So this is a assembler instruction, and it ends the program name main, which is right here. All right, so your program is going to look pretty much like this as an empty shell. I have a couple instructions here for you guys. You don't have to worry about those right now, but I just want to show you how to run this thing properly. So, and again, don't worry exactly about these instructions. I have two variables, a message, which is of type byte, an integer, which is of a number, which is of type integer, which we call dword, initialized to the number 13. So I get the address of my message. I put it in this register. I call the write string function procedure, and this will print this message. I get the number 13. I put it inside another register, and then I output that register. I print a new line. I will stop the screen for you guys to see. I return 0, and I end the program. All right, so this is a very simple program, and it's not meant to teach you assembler. It's just meant to teach you how to work with the SASM environment. Okay, just keep in mind that you're under settings, under build, you have to have your assembler set to MASM. Otherwise, this will not work. It's a different language. And set it to the Intel processor 86. Okay. Don't change anything here. SASM already must have set these things for you, and obviously it's only going to work if your MASM compiler is set. All right, click apply, okay. When you're ready to run, if you want to build the program, build, the log is going to show here. If you do have an issue, I've just removed one letter from the instruction. It's going to say there's an error. Go back and fix it. Rebuild. And then I can run in a new window. Right? If you just say build and run, you're not going to see anything. You just see the execution time and you don't see any of the output. Run in a new window. And here on a regular screen, a system screen, you see my output, which is the number is and the number 13 with a new line from the carriage line feed instruction. I only see this because of the call read int to stop the screen, otherwise I would not see it. So if you're just running the code, you can do this. You're going to have a shell program with the main proc under .code and the end main or main NP and end main instructions to end the program. Okay. Now, I also want to show you if you are debugging your code. It's slightly different. I'm going to show you a different file. So if you're debugging your code, so this is what I'm going to show you, the debug format, which is pretty much the same. You put your student name, description here, the libraries you have to use, constant section, data section. I have two data sections here, one for number, the other for messages. And your code now is going to start with start and it's going to end with end start. So this is for debugging. All right, so your original code, main proc, end main, and main end procedure cannot be debugged, but this can. All right, and this only just adds two numbers. So I put a message. I enter one number with read int. I store it in N1, and I enter another number into the register, and then I add the original number into the register, and then I print out the final sum. Okay. Now it looks weird. I have N1 and N1 here, but keep in mind that the user entered N1 into the register and I stored it into the variable N1, even though already has some kind of value there. And there is a new input into the register. So whatever it's in here now will get added to the original value of N1. So this is actually N1 plus N2. All we do again is build, no issues, run in a new window, making sure that again, under options build, I have MASM checked. All right, so run in a new window. So here's my window, my code is running. I am going to type 21 and I'm going to type 81. So obviously the answer is 102. The cursor is blinking here because of the read int instruction to stop the screen, otherwise I wouldn't see anything. All right, so this is pretty much the same as before. Now, I can debug this code. Now, the debugger does not work well with IO instructions, so I'm going to remove every one of these instructions and I'm going to use the values I have hard-coded for my program, which are these two. So now I am going to change this. Don't worry about this stuff now. Okay. All I'm doing is I am going to step through the code and I'm going to show you how you can see the contents of the registers as we move forward in the code. All right, so let's build the program again. Builds correctly. To debug, I am going to click debug. You see this yellow line, which is an indication that the operating system is now waiting here to execute the instruction on line 35, which is just a move of the variable N1 into the register EAX. Okay, to do that, you will either press F10 or F11. I have to press F11 because I'm recording this video. If I press F10, the video is going to stop. So I'm going to press F11, and you see the contents of the registers. I have on the debug show registers clicked because I want you to see the register. So I'm going to press F11 right now. And as I do, on the upper side here, you can see what's in each register. All of these registers, obviously I'm only using the first one, and some of the other registers that we have to check. I'm only interested in the register EAX, which now has the contents of N1, which should be the number 12, which it does. All I'm doing now is I'm going to execute line 42, which is add the contents of the variable N2, which is 43, to my variable, my register EAX. So I'm going to click F11 again. And after that, the assembler should have added the 43 to 12, which gives me 55. And this is exactly what I have. If I do it again, the execution is going to end because it's a return 0 instruction, and I will stop the execution right here. Program is over, but debugging helps if we want to see the contents of registers as we're moving forward with the code. So again, if you don't need to debug, you're going to main proc, main np, and main. And if you are going to debug, you're going to use start and then start exactly the way I have here. Okay, don't worry about the details of the language. We'll learn the syntax of the assembly language under MASM, but now it's important that you understand how to debug or just run the code normally. So I hope this video helps, and I may post future videos about specific issues with SASM in the upcoming weeks.